Good morning my friends. Welcome you all to Global MEP Training Academy. In this video, we are going to see one of the important topic which plays a main role in plumbing and HVAC design, that is occupancy or occupant calculations. So let's start the video. It is important to find out the occupant quantity in the project design because sizing of water supply tank and septic tank is completely dependent on occupant quantity. You see Abu Dhabi Regulation and Supervision Bureau, Dubai Municipality, and similarly Qatar Karama regulations, daily water consumption for different application is given. So simply we need to consider this daily water consumption and multiply with occupant or people quantity to size the water supply tank. So secondly, for HVAC, we need to add the quantity of people in each room to get the sensible and latent load. For example, in this HAP input data, you have to add the people occupancy quantity at this column, okay, to get the sensible and latent heat in the calculation. So similarly, for fresh air calculation, when you go to asterisk 62.1, for each person, some amount of fresh air is added. Like you see here, the CFM per person or liter per second per person. That means for each person, we have to add some amount of fresh air. So correctly selecting the occupant quantity, it will avoid the over design or inadequate design. And the third thing is, if you see here, it is important for architectural engineer to decide the number of exits and size of exits. It means the dimension of the exits. For that also, occupant quantity plays an important role. 4 methods to get the occupant quantity. Like the first one, you can see is from the architecture layout drawing, you can count the number of chairs and you can get the quantity. The second method, International Building Code chapter 10, there is a table, we can see that one. And third method, NFPA 101 life safety code, and finally the fourth one, asterisk 62.1 ventilation code. So let's start one by one. So I have shown here a office building. In this office building, you can see there are lots of offices. And there is a meeting room and there is a big hall. Okay, and there is a water closet, means there is a toilet located here, and there is a stair here which is going to the first level. But for our study purpose, I have shown only the ground level of the office building. Okay, so first what you have to do is you have to count the total permanent chairs. Okay, in this arrangement, for example, I'm going to count the permanent chair from here, from all this one, 1 2 3 4 5 6 7 8 9 10, and here 11 12 13 14 15 16 17 18. Okay, so 18 permanent chairs are here, and visitor chairs. So the visitor chairs, in front of permanent chair, you can see the visitor chairs. So this white color chair, so you have to add all these visitor chairs. So that is 36 number. And after that, there is a meeting room located here, and there are total 9 chairs are there. So I'm going to count that one also, and we have to have some important assumption, like this is the entry. So surely there will be a reception people. There will be a reception people here. So I'm going to add one quantity for the reception seat. And some important assumption is, you know that we have a meeting room in most of the design. I have seen like the designer has done the over design. That means what they are doing is normally they will count the quantity of all the meeting room chairs. Okay, but that is not correct. That is not the correct one, because you know the practical thing is the people in the office, I mean the permanent people, these people also will come for the meeting. Okay, so we cannot assume that if there are 9 chairs, all the 9 people from outside, I mean the new people, will come for the meeting. No, surely the permanent seating people also will attend the meeting. Okay, so we cannot simply take all the chairs in the meeting room for the water tank calculation. Okay, so that's the first mistake normally we see in the design. In the second thing, all the visitors meeting the office staffs will not come in a single time. Okay, so that's an important thing. For example, here in this room, room number 1 and room number 2, we cannot say that the 4 people will come in a same day for the meeting or for any office purpose. Okay, so here in total 36 number, there may be 10 number will come, sometime 5 will come, sometime 25 will come. So there will be different quantity will come for the meeting. Okay, to visit the office. Okay, so we cannot simply consider all the temporary and meeting room chairs for the water demand calculation. So let's see how it is done. Okay, so we need to consider 25% extra, consider as a safety for visitors. Okay, so let's see how it is done. Okay, so here what I'm going to do is the statistics number for the visitors one. Okay, so visitors seating place, that is statistics number total, the white color you can see, and this 9 number is comes from the meeting room. Okay, it's now 9 number come from the meeting room chairs. So total there are 45 numbers. I'm going to consider 25% of visitors and meeting room seating capacity. Okay, so I'm going to multiply with the 0.25 and I get 11.25. So I round off to the highest value, that is the total number. Okay, so the total person for the office is 80 number, that is a permanent seating one which you saw now, plus total number from the visitors and meeting room seating capacity, and one number from the reception. Okay, so there will be total 31 number for this office building. Okay, but one important thing here is if you see here, areas such as embassy, banks, post office, where people continuously available for complete working time. So in this type of area you have to consider some additional safety like 50% instead of 25%. So this is the first example. It is based on grass method. Okay, so first here we can see the building, office building. It has the break room and the office building. Okay, so in the break room is mainly for the eating purpose for the office employees. The total grass area of this room is, this building is 45 into 38 square feet. So it is 1710 square feet, and the occupant load we are going to find out from the IBC chapter number 10. Okay, so here I have given the screenshot for the business area. For the 150 square feet we have to consider 1 people. Okay, so this value I have taken from the area table. I will show you that. So here you can see the different application they have given the quantity, and I have considered the business use because this is the office building, comes under the business group. Okay, so for the business group, for the 150 square feet we need to consider 1 people. So I have considered the same total square feet divided by 150, it is 11.4, and I have considered total occupants. Okay, so this comes under grass area method, and the next one is we have to see what is the net area. So in the net I have shown the same building but with a different concept. So this building is considered as a courtroom. Okay, earlier it was office building, and here just assume that this is the courtroom. In this courtroom, this is the entrance of the building, and here these all things are like a ramp. Okay, to enter into the building, and here and this total building is the purpose of total building is serving as a courtroom, and there are 2 exit here. Okay, so what we are going to see in this method is, you can see here the total grass area, the total area is 45,000, means 45 into 38, that is the same square feet I have considered 1710. Let me open the earlier one, it is also 1710. Okay, there is no change in the total area, but the important thing we have to see the definition of IBC before finalizing this one. So the definition of IBC chapter number 2, it indicates that for the floor area net, the actual occupied area not including unoccupied accessory areas such as corridors, stairway, ramp, toilet room, mechanical rooms and closets. Mechanical rooms like a pump room, heat exchanger room, like that. Okay, so we should not include all these rooms, corridors and ramps, this type of things in the net area. Okay, but in the grass area there is no limit. We should not reduce anything. We should consider the full arrangement, like the floor area within inside the perimeter of the exterior wall. So whatever is there inside the exterior wall we have to consider as a full, that is the grass area concept. Okay, so that is a difference between grass and net. Okay, so let me open it again. So in the net, so 1710 comes from 38 into 45. Okay, so that is the first one, and from 1710 I have removed this 3 value which comes from here. The 38 is the area of this ramp, plus 16.3 is the area of this ramp, plus 14.76 comes from this ramp. Okay, so this 3 area I have removed, so the total answer you are getting 1640.94 square feet. Okay, so we are not going to stop only this point, and there is one more thing we need to consider here, that is, if you go to this one again, floor area grass, you can see here the thickness of interior walls. Okay, so this should be without deduction for corridors here, but here what they have mentioned here is different. So in the net area we have to remove all these rooms arrangements. That means in this arrangement it comes, we have to remove the thickness of walls also in the net. Okay, but in the grass area we are not going to remove the thickness of walls, and we are not going to remove all these rooms. Okay, we are going to consider as it is. Okay, so again I am going to remove the thickness of walls also from the value. Okay, so that means in this area the 55 square feet comes from the thickness of the wall. Okay, thickness of the wall. So all these thickness of the walls I have considered from all here, all these points, and the total area I get is 55. That one also I removed. So the total answer I am getting is 1585.94 square feet. Okay, so this is the total area, and this area I am going to consider the IBC chapter number 10 table, that is the courtroom. I have to consider 40 net. That means for 40 square feet I am going to consider 1 people. Okay, so 1585 divided by 40, I got the answer of 39.2. I round off to 40 occupants. Okay, so that is the difference between net and gross concept. Okay, the third method. In the third method it is based on NFA 101. Okay, so here also you can see the same concept of net and grass. Okay, so whatever the item seems like empty, it is the grass consideration, and for the net they have given the net arrangement. Okay, for the different application. Okay, so here also you can see the definition. If you go to the definition of this chapter number 3 NFA 101, the same concept like net floor area. For example, in the net floor area you see the width deductions. Okay, with the deductions of hallway, stairs, closets, soft thickness of interior walls, same like IBC chapter number 2. Okay, in the grass floor area there is no deduction. Okay, with no reduction. Okay, you have to consider as it is all the internal part of the walls. Okay, so that is the similar concept of IBC chapter 3, but the quantity is different. Okay, so let me show you the quantity. So if you see this business, this office building, like we see earlier, they have given for 150 square feet we need to consider 150 square feet we need to consider 1 people. Okay, so in IBC for 150 square feet we have to consider 1 people. In NFA 101 for the 100 square feet we have to consider 1 people for the business group like office building. Okay, so that is the difference between IBC and NFA 101. So the last method what we have here is * 62.1 occupant load method. Okay, so in this method I am going to show you the same example of business building. For example, in this one we have the office building and office spaces we have, and here what you see here is 5 people for 1000 feet square or 100 meter square. Okay, that means for 1000 feet square 5 people. For that means if I just do the interpolation, for 200 feet square there will be 1 people. Okay, it comes from 200 into 5 divided by 1000. So for 200 feet square I am going to consider 1 people as per * 62.1. Okay, so now let me show you the comparison of these 3 methods. So if you go to * 62.1 for 200 feet square 1 people, for NFA 101 100 feet square 1 people I need to consider. Then IBC chapter number 10 150 feet square 1 people. Okay, so this is the comparison of all the 3 methods. So for me, based on my experience, I will consider * 62.1 for the calculations related to HVAC, for the fresh air calculation, for the cooling load calculation, and I will mostly I will follow NFA 101 for the water supply tank sizing. Okay, so this is based on my experience. So now we got the occupant quantity, and with this quantity we can easily design the water supply tanks. Okay, so in the next video I am going to cover the water supply tank design for different tanks. Like I am going to teach you the GRP tank design, PVC tank design, RCC tank design, or cylindrical tank design. So how we can do the design for all these tanks I will cover in the next video. So if you like my video, please like, subscribe, and mainly comment in the comment section. Okay, if you want any other topic, please put your comment in the comment section, and if you have any doubt in your current project, design or installation, whatever, you can send a mail to me with your doubt. I will quickly respond for your doubts. Okay, thank you, bye bye.